Hello and welcome back to AtheroTalk. I am Marion Mussbacher from the Department of Pharmacology, University of Graz, Austria. Today, we are joined by Professor Dagmar Kratky, who is Professor of Biochemistry at the Medical University of Graz, Austria, and a leading expert in lipid and energy metabolism. Professor Kratky has held prominent positions in the scientific community, including serving as president of the Austrian Atherosclerosis Society and contributing to international organizations such as the European Atherosclerosis Society and the European Lipoprotein Club. Through numerous scientific publications, competitive research funding, and international collaborations, her work has significantly advanced our understanding of how metabolism, especially lipases, influence human health and disease. Professor Kratky, thank you so much for joining us today.
Thank you so much for inviting me and giving me the opportunity to talk to you.
In the AtheroTalk, we want to give our listeners the chance to get to know more about you and your research. So could you please introduce yourself to our listeners?
Yeah, so I studied chemistry at the University of Graz, where I finished also with my master thesis in the lab of Hermann Esterbauer, the first time where I got exposed a little bit to lipids. And then I did my doctoral thesis with Rudolf Zechner. And shortly thereafter, I was postdoc, but just for 5 months at the University of at the Medical University of Graz, at the Institute of Pathology, and then I got an assistant professorship at the University of Graz at the Medical Institute of Medical Biochemistry.
Let us have a mixed view about a typical day in your life from a professional and from a personal perspective.
Okay. Yeah, well, so this might not be too different to other scientists. Maybe that I just get up very early for a basic scientist, at least. So I'm always in the lab before 8. I try to keep the balance more to science, and so that I can meet with my PhD students, with my postdocs, that I don't do too much of administrative and management work. So although I have some duties at the department and the university, so I'm in the Senate and I'm in several committees. And as a female, you're always asked to go to all these committees. But what I learned is also to say no, and this is maybe something what is also important to share with the younger scientists. So don't say yes to everything. Also say no, and don't take on all the responsibilities they ask of you. I think I'm very well organized, so I dedicate a lot of my time to talk to my students. My door is always open to them. So I'm not hiding here in my room, so everyone can always come and ask me questions. And then, of course, I write and correct manuscripts. I correct theses. I'm in thesis committee meetings. I also have to organize or motivate people in our SFB lipid hydrolysis. So for that to increase collaborations and to keep this all ongoing. And apart from that, so in my personal life, I I got married relatively at a young age, so which means that at the age of 27, I already had 3 stepkids and 2 kids of my own. And this was also why it was difficult, or almost, yeah, no, it was difficult, which I did not do then, to move somewhere else. So that's why I studied in Graz. I got my first position in Graz and I stayed here. But as Graz is a great city for doing lipid research, I think it was fine for me and it worked out.
Thank you very much. And I think it's a very good advice, this saying no. But personally, I think it's quite hard to do this.
Yes.
What about your after work? About your hobbies?
Well, my hobbies are I love hiking. I love doing several multi-day biking trips. And I love skiing in the winter, so which is not so easy now when you are in Graz, but at weekends. So I really want to go out into nature and be outside.
Thank you. So, what first drew you to studying lipid metabolism and this field of research? Um, was there a particular moment or a discovery in your career that really shaped your scientific direction?
Yeah, well, as I said, I did my master thesis in Hermann Esterbauer's group, and Hermann Esterbauer, he was a pioneer working on oxidative stress, free radicals, and LDL. So this was the first time that I got exposed to lipid metabolism, let's call it like this. And then when I moved on to do my doctoral thesis in Rudi Zechner's lab, I was working on the role of endothelial lipases, on endothelial lipase, and I deciphered the role of this enzyme in an alternative fatty acid uptake mechanism in LPL deficient adipose tissue. And in that time, so I got very much involved in lipid metabolism. I got the passion for lipid metabolism and lipases. I learned about mouse models, working with mice, and yeah, and this is where I then stayed and where I then tried to go on and have my own ideas. And maybe the moment, so there was more a moment that shaped my scientific direction was when I got offered this assistant professorship at that time by Gerd Kostner as the head of the Institute of Medical Biochemistry. So where I applied and I got this position. And this was just starting my own group and trying to find a niche in lipid metabolism not everyone else was doing in Graz. So people were more interested in lipases in adipose tissue and liver. And so I tried to find my niche in the role of lipases in macrophages and atherosclerosis.
And you very successfully found this niche. So, did you face any obstacles along the way because of being a woman? I mean, you already told us having three stepchildren and two own children. It is quite challenging, I can imagine. But were there also other obstacles when you started?
Yeah, so for my clear answer is no, at least not that I realized it in any way. So no. I think, and this is what you said, it's not, I was not discriminated, but it's still these obstacles that scientists or female scientists have. Yeah, well, we have them, but it's also something what we as a woman we have to do. We have to try to go on. Not we have not studied, then staying at home with our children. This is also what I try to tell my female team members. So try to come back as soon as possible after you got birth to your babies. Yeah, and what you still see, so last week when we were at our national conference, that we have so many talented young female scientists. So there are more than males. But when you then look up at the group leaders, we're just a handful. And this is something, yeah, which we ourselves maybe have to work on. And I guess that also females still have this imposter syndrome. They are not as self-confident as males are. And yeah, we can just try to help our colleagues to fight against this.
Yes, and I think I have to add, um, Dagmar is really a person that really supports also female scientists, strongly supports them.
Thank you.
Absolutely. So let's dive into your research. Your work often looks at how cells store and mobilize lipids. Can you explain why this balance is so important for our health?
Yeah. So on the one hand, fat is a fuel. On the other hand, it's also a toxin. So this means that we need this balance between storage and mobilization needs to be tightly regulated, because if the storage capacity in the adipose tissue exceeds, then this fat spills over to ectopic tissues like the liver, the skeletal muscle, the pancreas, and then this leads to these lipid-associated metabolic disorders like fatty liver disease, insulin resistance, or beta cell dysfunction, and also, of course, atherosclerosis. And on the other hand, if we have an excess of mobilization, so then we have too many fatty acids that are released from, for example, the adipose tissue, then this also leads to lipotoxicity and this lipid-associated metabolic diseases. So this means that the precise control of fat storage and mobilization is essential for the metabolic health across all of our tissues.
So, what excites you most about lipases and lipid metabolism?
Well, maybe because they convert these inert neutral lipids into into signaling molecules. So I think this is mostly fascinating, and thereby it also affects gene expression, it affects signaling, it affects insulin signaling, so it affects so many different pathways. And most of these lipases, or let's call it lipid hydrolases, are disease relevant, and that the dysfunction in lipid metabolism has system-wide consequences. So if we just think about obesity, or in this case, in this talk on atherosclerosis and cardiovascular diseases.
And now to my favorite question. So, which is the most important lipase in our body, and which one is your favorite lipase?
So I guess you know that there is not one most important lipase, because there are so many, and this just depends on its context and its localization depending. And if you just think about the circulation, and this is what every atherosclerosis researcher also knows, this LPL, how important this is, because loss of this enzyme leads to familial chylomicronemia. We have pancreatic lipase, which is important to digest the dietary triglycerides in the gut. And then, of course, we have your favorite lipase, adipose triglyceride lipase, which is the most important enzyme, I would say, for neutral lipolysis, for start of the first step of the lipolysis by degrading triglycerides. And while my favorite enzyme, or let's call it not the favorite enzyme, but maybe the enzyme we are mostly focusing our work currently on, is lysosomal acid lipase, which hydrolyzes, which is to date the only known enzyme to hydrolyze neutral lipids like triacylglycerol, diacylglycerol, monoacylglycerol, arginine esters, but mostly cholesterol esters within the lysosome at acidic pH. And patients who are affected and who are affected in its severest form, they die within the first 4 to 6 months of age. So it's a very crucial lipase that needs more to be studied.
A very diplomatic answer. But the question is, are there still new lipases that need to be discovered, and how would you discover them?
Yes, I think so, that there are other lipases that we still do not know yet. In the SFB lipid hydrolysis, we have already identified more than 200 enzymes, which are potential lipid hydrolases. and we are so in the human and mouse genome, and we are expressing them in XP cells so that we have now a library of approximately 250 human and 250 mouse and human genes, which we are screening against different lipid substrates. So we check whether they are active or which enzymes are active against which lipid substrate. And with this library, we have already identified additional, so like 17 enzymes that were not known to be lipid hydrolases. So not only lipases, but lipid hydrolases. And we also assigned new functions to already known enzymes. So, and my answer, yes, clear, yes, we think that there are still lipases, lipid hydrolases that need to be discovered.
So a lot of exciting things are already, they need to be discovered.
Yes.
Um, so have there been any surprising findings in your research that challenged what scientists previously believed?
Yes, and this is so coming back to my most favorite lipase with lysosomal acid lipase, LAL, where we realized that so it was always described that this is the lipase that hydrolyzes triglycerides, cholesterol esters within the lysosome. But we realized in the lysosomal acid lipase deficient mouse that we see a huge accumulation of cholesterol esters, no matter which tissue you look at, which cell type, which cell, but the accumulation of triglycerides is much less pronounced, and even not, we don't see it at all. And so we believe that there is an additional lipase in uh, in a lysosome that hydrolyzes triglycerides. And so we have some candidates in the pipeline which we are currently focusing on.
Very exciting. Looking forward to this. And one quick lighter question. If you could bust one myth about lipids instantly, what would it be?
I thought about this question, and I first wanted to say that statins don't harm your brain or something like this. But then I thought that the myth that kids do not need lipid check is one very important one, because we know, we also heard last week that familial hypercholesterolemia is so common. So just 1 in 250 individual is affected, and is silent early on. So it would be so important to screen at least every individual, at least during the adolescence, for lipids to combat the disease much earlier than we do it today.
I couldn't agree more. So, definitely. So, looking ahead, what are some of the biggest unanswered questions in lipid metabolism?
Well, coming back again to what I already told, so for us, the biggest question is which other lipases, acyltransferases, transacylases are yet to be discovered, and whose function do they have? In general, I think one big question is about these sex-specific strategies we can find to combat cardiovascular disease. And another question which I think is very important is whether or about the circadian clock of lipid synthesis and lipolysis and lipid metabolism, and whether it is better to eat in the morning or in the evening, in the afternoon, together with this exercise stuff. So whether this might also be a way to improve cardiovascular treatments.
And are there emerging therapies or approaches targeting lipid metabolism that you find particularly promising?
Yes, I think these LP little a lowering strategies, but these targeted approaches where they result in more than 80% decrease in LP little a are interesting. And we will have to see in the future whether they also reduce cardiovascular events. So hopefully they do. The gene therapy approaches for lysosomal storage disorders are very important. And if we find safer and more efficient nanoparticles for efficient in vivo delivery, this is a challenge, but would be very, very important. And of course, these GLP-1 agonists and the dual and triple agonists that all favorably shift lipid metabolism and cardiometabolic risks, so they decrease all these risks. This is they are very cool and interesting and exciting, and I just think that it is important that we find a way to preserve the lean or muscle mass. So but there is a lot going on, and yeah, it's interesting what we will find out in the next couple of years.
Yes, we will learn a lot. That's true. So now that we are coming to our end, we have a section that is dedicated to failures, which we call the graveyard of ideas. So most of the time, we only hear success stories of other researchers, which makes some of us question ourselves. We have talked about the imposter syndrome. So we want all researchers to know that failure is part of the game, so part of the process. So we decided to ask everyone in this series of interviews to contribute an idea to our graveyard of ideas. This could be a story about a grant you are passionate about, or any kind of failure that you faced during your academic journey. So, what is your contribution to our graveyard?
Well, there is not just one, there are many, as you said. So we live with failures and we have to deal with them. So one of my, in my opinion, best grant applications never got funded. So, and during writing and rewriting, I got new ideas and better ideas, and but still it never got funded. And at that time I was just lucky that I got a PhD position from the medical university for our this molecular metabolism program which we have. But without that, this one of my best ideas would have never got published. So this was it. And yeah, I think what I can just again share with the young researchers is that it's so important to stay persistent, try again, never give up, and don't take it personally, because it's not against you or against your idea, and you will have luck, you will proceed with your ideas. Just try again and it will work, hopefully.
That is very valuable advice. So, thank you so much for joining us today. It's been a pleasure speaking with you. And thanks to our listeners for tuning in to AtheroTalk. Stay curious, and until next time. Thank you.